whenever nitrosyl gets involved in bonding, so these three electrons will be involved, will participate in bonding, and since these three electrons are polarized on nitrogen, therefore nitrosyl will get linked or will offer nitrogen uh, at least toward metal center for bonding nut oxygen. So whenever you are drawing the coordination compounds of nitrosyl, so always nitrogen is oriented toward metal center, not oxygen. Now let diagrammatically look at the location of these electrons in orbital. So these are now the orbitals which we call anti-bonding molecular orbitals. And if you remember, so if this oxygen also possesses such type of orbitals, so they will have orientation in this direction. So the overlapped area of these orbitals is not possible. The orientation of these orbital is not appropriate, therefore they will never overlap with each other in order to afford another bond between nitrogen and oxygen. This is the pair of electrons which was actually in sigma star of molecular orbital diagram of nitrosyl. So this pair is now regarded as lone pair, unpaired electron which exists in pi star orbital. Now you know that from where this electron is from molecular orbital diagram. Theoretically, now we know that these electrons are polarized on nitrogen, and actually the situation is also in closer agreement with the theoretical findings that these electrons are polarized on nitrogen, and nitrogen gets involved to metal center or any whenever any bond between nitrogen and other species form, so nitrogen will be offered first as compared to oxygen. There are very little examples in literature where oxygen is involved. Now for this molecule, we have to look at hybridization around nitrogen. You know about hybridization, that how we have to determine hybridization of a species. Now, this hybridization uh, is now uh, for example, lone pair of electron, general formula is lone pair of electrons and number attached to to an atom. When this number is equal to 2, the hybridization will be sp, and when this number is equal to 3, so hybridization will be sp2 and so on. Around nitrogen, if we count the number of atoms attached, so there is one atom, and number of lone pair of electrons, so there is one lone pair, and collectively both of them make 2. So 1 plus 1 is equal to 2. It means nitrogen is sp hybridized, and since this is unpaired electron, so we will ignore it for the time being because the hybridization cannot be in fractions. Now there are two possibilities. If nitrosyl offers one electron for bonding, and definitely this electron is higher in energy, so this electron is more polar as compared to the pair of electrons. So what will happen? The metal, if this approaches the nitrosyl ligand, so metal will attack this orbital first, and this will be the orientation of metal and nitrosyl fragment. So if you look at nitrosyl metal fragment, it will make an angular or bent structure. And on the other hand, if metal is electron deficient, in this case metal is electron rich. And the other point is that if the metal possesses unpaired electron, then that unpaired electron or half-filled orbital will overlap with this half-filled orbital and bond will be formed, because normally in normal bonds there are two electrons which participate between two bonding species. On the other hand, if this pair of electron is involved and the unpaired electron of metal is oriented toward the pi star orbital of nitrosyl, so these orbitals are now suitable for overlapping, and these orbitals are suitable for overlapping. So in this case, one bond will be sigma, which is in between the two bonding nuclei, or the electron density lies in between the the nuclei of the atoms are on bond axis, and above bond axis or maybe below bond axis, if the electron density lies between two bonding species, then such bond is normally called as pi bond. So metal will now establish two bonds with nitrosyl. One is sigma bond and the other one is pi bond. And if you look further into details of this bond, so this is coordinate covalent bond and this one is purely covalent bond. In this case, the bond between nitrogen and metal is far stable than this case, because here the bond was established with the help of two electrons, one each by metal and nitrosyl. And in this case, nitrosyl or nitrogen offers two electrons for bonding with metal center, and then metal shares its one electron with nitrogen. So double bond will form, and this double bond is definitely stable or stronger than the single bond. Now look at the fragment metal nitrogen oxygen fragment. So this metal nitrogen oxygen fragment is it seems to be linear. So whenever metal afford linear nitrosyl with the nitrosyl ligand, it means the nitrosyl is two electron donor. And whenever bent structure is afforded, so in bent structure the nitrosyl is one electron ligand. Now the conceptually we have to prove whether this is feasible model or this is feasible model. Now look at hybridization. So around nitrogen, hybridization was 2 in starting nitrosyl. In this compound where metal establishes a double bond or multiple bond with nitrosyl. So in this case, if we look at hybridization of nitrogen, so now nitrogen is attached to metal on one side and oxygen on the other side. There are no lone pair of electrons because there was the one lone pair which was already present with nitrogen that got involved in bonding with metal center. Now we will either consider the pair of electrons are metal, but metal is attached, therefore we will preferably count this metal not pair of electrons, because pair of electron is confusing. Here we have two pair of electrons. So in this case, whenever bond is established between two atoms, whether it is single bond, double bond or triple bond, but the entity will be counted as single, not double or triple. So two atoms are attached, so nitrogen has sp hybridization around it, and in this case also nitrogen was sp hybridized. On the other hand, this nitrogen is now attached to one atom on this side, that is oxygen. On the other side it is attached to metal, and it also possesses a lone pair of electron. So 1 plus 1 plus 1 is equal to 3. It means nitrogen got sp2 hybridized in this case. And now look at the look at the conceptual stability of the system. So whenever there is disorder in the system, there is rearrangement in the system, or there is some sort of disturbance in the system, so that system is least stable. And if you look at these two systems, in one the hybridization around nitrogen does not change, and on the other hand hybridization around nitrogen changes. So logically we have to conclude that this system is least feasible as compared to this one. Uh, this overall model where there was no gain or loss of electron from metal toward nitrosyl or nitrosyl toward metal, therefore this model is called covalent model. Next model is called Ionic model, and since the name indicates, in Ionic model there will be either gain of electron from one species to the other one, or at least there will be a transfer of electron from one species to the other one. So nitrosyl, there are two possibilities for nitrosyl: either to accept an electron in this orbital, because here we have unpaired electrons, and that incoming electron will get pair off with this electron. And on the other hand, nitrosyl can get rid of this electron. This electron can be donated easily, and whenever this electron is donated, so nitrosyl will have this empty orbital. So there are both the possibilities. So in case of gaining of another electron from any foreign species, nitrosyl will get negative charge, and in case of donation of this electron, nitrosyl will get positive charge, or the ligand will be cationic. So this is also an example of cationic ligand in coordination chemistry, where nitrosyl donates this electron to other species in order to get a positive charge. And in case of that positive charge, again the system possesses this lone pair of electron and can act as a ligand. Now, in this case, whenever an electron is accepted from other species, nitrosyl will have, or it will get negative charge. And in this negative charge species, what will happen? Now, in this case, the hybridization around nitrogen, as we discussed earlier, is sp, and in case of sp, this fragment is logically linear, and we have to place it linear. So whenever another electron is accepted, the orbital will rearrange themselves. Electron density will get rearranged around the nitrogen, and on the basis of this rearrangement, also we can explain this on the basis of hybridization around nitrogen. So nitrogen now has three species around it. Two are unpaired, two are lone pair of electrons, and one is oxygen, and this total number is 3. So in case of 3, the hybridization around nitrogen is sp2, and in sp2 we have to place these species around nitrogen in three-dimensional space in the form of trigonal planar, and this is the trigonal planar structure around nitrogen. So this is because of the hybridization, we rearrange these orbitals around nitrogen, and this electron transfer can in coordination chemistry can be from metal ligand fragment. This ligand can be any sort of ligand in coordination chemistry, which is capable of donating one electron to nitrosyl. On the other hand, if nitrosyl donates its electrons, so the orbital will get empty since there is no change in hybridization, and because of this no change, we have to keep or to leave this nitrogen, oxygen, and electron pair undisturbed or in the same way as it was. And in this case, electron is transferred to metal ligand fragment, or electron is transferred to a metal. Now, whenever further reactivity is explained, or we want to explain further reactivity, in this case, now we have to distinguish between these two orbitals. In diagram, they are similar, but if we look at the nature of electrons, so nature of electron is not similar, because the electron which has been accepted by nitrosyl is actually in pi star orbital, and this one is pi star orbital. Uh, uh, let, if you consider the previous diagram which we discussed, the molecular orbital diagram of nitrosyl, so this was actually pi star orbital, and this one is sigma star orbital. The energy of pi star orbital is more than sigma star, so the electron which has been accepted by a metal accepted by nitrogen from a metal center, it is actually in pi star orbital, and this is the lone pair which was already present on nitrogen. This is sigma star orbital. The energy of this orbital is more than this one. So what happens when metal approaches the ligand, so this unpaired this lone pair of electron which is higher in energy will get preferably first in bonding with the metal center, and bond between metal and nitrogen will establish in this way. And this fragment, if you look again, this is regarded as bent structure or bent nitrosyl. On the other hand, whenever uh, electron is accepted is donated by nitrosyl, so this donation of electron makes this orbit empty, and metal accepts that electron. So now metal will offer its empty orbital toward this orbital, and or metal will orient its empty orbital toward this orbital. Overlapping will take place, and sigma bond will form. On the other hand, electron which has already been transferred to metal fragment, Metal will offer that electron pair for bonding, and a bond which we normally call as ionic bond. So this is coordinate covalent bond, and this one is ionic bond. So in ionic bond, uh, this will be more appropriate if you put this electron in this orbital. So here we will have two electrons, and here we will have one electron. This orbital or this species, and this is also, I'm sorry for this, this is not carbon, rather this is nitrogen. So this is positively charged lobe and this is negatively charged lobe. It means this is electron rich lobe and this is electron deficient lobe, or empty orbital and fill orbital. And again, uh, in other words, a coordinate covalent bond will form where electron density will flow from metal toward nitrogen, and in this case the electron density will flow from nitrogen toward metal center and multiple bond will form. Now, in this multiple bond, what we observe, the hybridization around nitrogen is unchanged. Therefore, the geometry around nitrogen will also remain the same or linear, because nitrogen